Rising from the waters of the Arabian Gulf, Palm Jumeirah stands as one of the world's most ambitious artificial islands, transforming open sea into a vast engineered landscape through large-scale dredging, land reclamation, and marine construction. Before the island could take shape, engineers first had to map the seabed, extract millions of cubic meters of marine sand, reclaim vast areas of open water, stabilize the newly created ground, and install the critical infrastructure hidden beneath the surface. But every stage of Palm Jumeirah's construction began with a single objective: understanding the seabed conditions that would ultimately support one of the world's most ambitious artificial islands. Before Palm Jumeirah can emerge from the waters of the Arabian Gulf, engineers must first create an accurate map of the entire seabed. Millions of sonar measurements are collected across the future island site, revealing the hidden contours beneath the Gulf waters.
The depth reading on Sector 4 is fluctuating.
I see it. Rerunning the sonar sequence now.
Advanced processing systems transform this raw hydrographic information into the first precise digital model of Palm Jumeirah's foundation. With the bathymetric survey complete, engineers can now investigate the deeper geological conditions that will support the future island. Before construction begins, engineers must confirm that the seabed beneath Palm Jumeirah can safely support one of the world's largest artificial islands. Powerful offshore drilling systems penetrate deep below the Gulf floor, uncovering the geological layers hidden beneath the future development. Every recovered core sample provides critical evidence about the strength, density, and long-term stability of the island foundation. Extensive laboratory testing reveals how the seabed will behave under the enormous weight of millions of cubic meters of reclaimed sand.
The load distribution seems stable at peak stress.
Yes, the settlement curves are within tolerance.
With the foundation conditions fully verified, Palm Jumeirah is ready to enter the next stage of construction: large-scale offshore dredging. Before Palm Jumeirah can rise from the Arabian Gulf, engineers must first secure vast quantities of marine sand from offshore borrow areas. Specialized trailing suction hopper dredgers lower powerful drag heads onto the seabed, extracting the material that will eventually form the island. As the drag heads sweep across the seafloor, high-capacity suction systems draw a continuous mixture of sand and seawater into the vessel. Advanced navigation and monitoring systems guide the dredging process, ensuring efficient extraction while protecting the surrounding marine environment. Inside the hopper, heavier sand settles while excess water is separated and discharged back into the Gulf. By concentrating only high-quality marine aggregate, each dredger maximizes the volume of usable material delivered to Palm Jumeirah. With thousands of tons of reclaimed sand secured on board, the fully loaded vessel turns toward the construction zone where the future island will begin to take shape. To create Palm Jumeirah from open water, cutter suction dredgers begin relocating vast volumes of seabed sand through hydraulic placement. Floating pipeline networks transport millions of cubic meters of marine sand toward the future Palm Jumeirah footprint. Using precise engineering coordinates, the sand slurry is deposited in controlled patterns that begin forming the first Palm Jumeirah fronds. As new land rises above the waterline, bulldozers continuously reshape the reclaimed sand to maintain the island geometry. With each layer of deposited material, the distinctive outline of Palm Jumeirah becomes increasingly visible in the Gulf. Although the island now stands above sea level, the reclaimed sand remains unstable and unsuitable for construction. To prepare Palm Jumeirah for development, massive vibro-compaction rigs begin stabilizing the newly reclaimed ground.
Alignment confirmed. We are clear for descent. Roger.
Lowering probe. Initiating compaction sequence.
Heavy vibro-float probes penetrate deep into the sand, targeting weak layers beneath the future island's surface. Powerful vibrations force loose sand particles closer together, significantly increasing foundation strength. Engineers monitor density and settlement data to ensure Palm Jumeirah meets strict geotechnical standards. Once compaction is complete, the reclaimed island becomes a stable platform ready for future infrastructure. With the island core secured, construction advances to the protective crescent breakwater surrounding Palm Jumeirah. Specialized marine barges position massive armor stones along the perimeter to defend the island from Gulf waves. Layer by layer, the interlocking rock barrier absorbs wave energy and protects Palm Jumeirah from erosion. When the 11-kilometer crescent breakwater is completed, Palm Jumeirah gains the sheltered waters required for the next infrastructure phase. To connect Palm Jumeirah's growing districts, engineers begin constructing subsea utility corridors beneath the marine channels. Powerful dewatering systems remove seawater from enclosed cofferdams, allowing excavation to proceed below sea level. Massive precast tunnel segments are lowered into position, creating protected infrastructure routes beneath the seabed.
The shear connectors look good here. Yeah, agreed. Let's sign off on this section before the next pour.
These underground corridors will carry the essential power, water, and communication systems needed across Palm Jumeirah. Once installation is complete, the trenches are sealed and the seabed is restored above the hidden infrastructure network. With critical utilities protected below ground, construction advances to the island's surface transportation system. Heavy earth-moving equipment shapes the road foundations that will connect the spine and fronds of Palm Jumeirah. Industrial paving systems place and compact thick asphalt layers to create durable transportation corridors. Strict quality controls ensure every roadway section meets long-term structural performance requirements. The completed road network establishes the primary transportation backbone of Palm Jumeirah. Alongside the roads, engineers install the utility corridors that will distribute water, electricity, and communications across the island.
Okay, easy pressure, set it down. All right, we're clear up top.
Heavy pipe-laying systems position large water mains and utility conduits throughout the developing infrastructure grid. Advanced fusion welding creates continuous pipe networks capable of serving Palm Jumeirah for decades. Power cables and fiber optic systems are then integrated into the underground utility network. Once backfilled and compacted, the island's essential infrastructure systems disappear beneath the surface. With construction largely complete, engineers begin a long-term monitoring program across Palm Jumeirah. High-precision positioning systems continuously track settlement and movement across the reclaimed land. Laser scanning and satellite monitoring verify the stability of roads, breakwaters, and critical structures. The collected data confirms that Palm Jumeirah has achieved the structural performance required for permanent operation. Built from open water into one of the world's most ambitious artificial islands, Palm Jumeirah stands as a landmark achievement of marine engineering. From the first sonar survey to the final stability inspection, every stage of Palm Jumeirah was shaped by engineering precision on an extraordinary scale. Millions of cubic meters of sand, thousands of armor stones, and years of construction transformed open water into a permanent new piece of land. Today, Palm Jumeirah stands not only as an artificial island, but as a remarkable demonstration of modern marine engineering and human capability.
NextGen Machine Works, building the impossible. Subscribe to join the future.